students, and welcome to Engineering Mechanics Lecture 3. In this lecture we are going to talk about the resultant of forces, where multiple forces will be applied on a body, and we are going to find out the resultant of those forces. We are also going to discuss the moment produced by forces in various bodies, and also we are going to talk about the couples moment. So when two equal and opposite forces are applied at one body, so we are also going to solve some problems at the end of the lecture. Starting with the resultant force, which is actually defined as a single force that can replace a system of forces and produce same effect, which means that if there are many forces applied in a force system, for example in this case there is an F1 and F2 applied on the body of mass m. Okay, so we can replace these two forces with just one force that is able to produce the same effect, and that one force is known as the resultant force. All right. So there are few basic steps that we can follow to calculate the resultant of these forces. The first step is to evaluate the x and y component, which means that each of these forces has x and y component. For instance, for the F1 we have an x component which we can call as F1x, and it also has a y component which we can mention as F1y. Okay, and similarly the F2 also has two components. One is the x component which we can mention as F2x, and one is y component, it can be mentioned as F2y. Okay, so there are a total of four components in this case. Two are the x component and two are the y components. Okay, so we are going to resolve this into components. In the previous lecture we did talk about how to resolve a force into in x and y components using the angle theta. So in this case, if you are not sure how to do that, just please go back and watch that. Now for the F1 we have an F1x which will be actually equal to, in this case, F1, and because it is adjacent to the theta, so we will use cos theta to calculate it. Alright, and then similarly there will be a y component of F1 which is actually perpendicular to the theta, and that's why we will use the sine theta to calculate it. So that will be F1 sine of theta. In this case theta is 26 degrees in both cases, okay, because it is for F1. Alright, so these are the first two components that we calculated, and then we can move on to calculate the F2x, which will be the x component of force F2. Okay, and then it will be as F2x will be equal to your F2, and because it is adjacent to the angle 57 degrees, so that will be as F2 cos of 57. Alright, and similarly the y component of F2, so F2y, that will be equal to F2 sine of 57. Alright, so you are going to consider for both the F2x and F2y, you are going to consider this angle. For F1 and F1x and y, you are going to consider the 26 degrees. Alright, so we got four components in this case, and this is how we usually resolve a force into two components. So what we got is, we actually got F1x, we got F1y, from F1 we got F2x, and we also got F2y from resolving F2. Now the second step, this is what we got are done so far. We are done with the step 1. In the second step, what we are going to do is we are going to calculate the Rx and Ry, which are the x component and y component of the resultant force. Okay, the Rx would be equal to the summation of x forces, and Ry will be the summation of y forces. So there are two forces in the x component. One is the x component of F1, one is the x component of F2, which is F1x and F2. Okay, so this is 1 and this is 2. Similarly, there are two components for the resultant y, and that is one is the F1y, second is the F2y. Okay, so your Rx will become equal to, there is summation of fx forces. Okay, so we have our f1x and plus f2x. Similarly, your ry will become equal to f1y plus f2y. Alright, so we got the rx and ry. Now this is what we got. We got the resultant force x component and resultant force y component using these calculations. And what we are left with, we are left with a component of the resultant in the x direction, a component of the resultant in the y direction, and they are actually perpendicular, having 90 degree. Now once we have some triangle like this, we can actually calculate the third side using the Pythagoras theorem, which is actually uh, r square is equal to your rx square plus ry square. Okay, you take the square root on both side, so you are actually left with the formula, this one that is right here. This will give you the magnitude of the resultant force r. Alright, so it will give us this magnitude. Now we already know that a vector, for a vector the magnitude is not enough. You also need the direction, which is the theta. For example, it can be this angle in this case. Okay, so you also need the theta. Now when you look at this, the perpendicular is ry but the base is rx. Okay, so we know that the tangent theta is equal to perpendicular divided by base, which is ry divided by rx. So to calculate theta, we can just use tangent inverse. So tangent inverse of ry divided by rx. Okay, so once we do that, we should be able to also find out the orientation. Now to define our vector completely, we need the magnitude, we also need the angle theta. Okay, and that's how we actually calculate the resultant of force. So first step, calculate the components of all the forces, the xy components. Then sum the x forces, summation of y forces, and that will give you rx and ry, which you can then use to calculate the resultant force magnitude. And then we use the tangent inverse to calculate the orientation of the resultant force. Simple as that. Alright, okay, so let's look at this example where we have three forces, which is actually F1, F2 and F3 applied at this specific point. And the angles are given. For example, for this F3, this is 90 degrees, so no angle is given here because it's 90. And then we have for the angle force F2 we have 45, force F1 we have 30 degree. Alright, now again we need to calculate the resultant of forces using the formula. So let me take you to okay, so let's see how let's calculate them. We have three forces. Let's start with the first force, F1. Okay, so for F1 we have an angle of 30 degrees, so it will have two components. One will be the x component and then we will have a y component. Alright, so the x component is negative x direction, so whatever the value is, it will be taken as negative, the other side is positive. So in this case, because the x component is adjacent to the angle, so to calculate the f1x, this will be our f1x. Okay, so to calculate the f1x, we will use f1, and because it is adjacent to the theta, so we will use cos of theta. Theta in this case is 30 degrees. Okay, similarly the second force, which is f1y, okay, and it is in positive direction. X is in negative, so we will use the negative sign with it, but the y is in positive y direction because this is positive y, this one is negative y. Okay, so it will come out to be f1 because this is perpendicular to the angle, so that will be your f1 sine of 30 degrees. Okay, and so we got these two components. Let me calculate them first and then we can move forward. So in this case f1 is 50. Okay, and we are going to have the f1 cos of, so f1 cos of 30, which is actually sorry, so 50 cos of 30. Okay, so it is equal to 43.30. So we got 43.30. All right, and then second is f1 sine of 45. So we have f1 as 50, and then we are going for the sine 45. So that is equal to 35.35. So we got 35.35. All right, now once we have these two forces, the component of f1x and then the second component, which is f1y, we have both the components now. For the f1, let's go on and create the components for the second force, which is f2 here. So f2 has again two components. One component is your x component, second component is your y component. So this can be f2x, this is f2y, and the angle adjacent to the angle is adjacent to the x component. So to calculate the x component, we are going to use the cos theta. Simple as that. Okay, so let's go. f2x is equal to f2 cos of 45. We are using cos because it is adjacent to the angle. And the second component will be f2y, which is equal to f2, because the angle is perpendicular to this component, so we will use sine 45. Okay, let's calculate that. f2 in this case is what? f2 is actually 75, so I will replace this f2 with 75. Alright, 75 cos 45, 75 sine 45. It is 53.03, and also sine 45 would be the same, I think. 75 sine 45. Okay, 53.03. So in both the cases it is actually same, 53.03. Also keep in mind this both will be positive because it is in positive x direction, and the y is also in the positive y direction, so both will be positive in this case. But in this for the f1, the x component was negative, so just let me get it negative so that we don't forget it later on. Now the last force is easier one, because this f3, it is acting directly in the negative y direction. Okay, so it's completely in the y direction. There is no part of it that is in x direction, so you can directly write it as that f3x is equal to 0, and then f3y is equal to 50 Newton, because it's completely in the y direction, negative 50. Keep in mind, because it is in the negative y direction. Also if you are confused in that, you can actually think of it as having a 90-degree angle, and then you can use the cos and sine theta. In this case sine 90 will be 1, so you will again get the y component as 50, and cos of 90 is 0, so you for the x you will get 0. But it's better to actually look at the situation and understand from that. Alright, so now we are going to calculate the Rx and Ry, which are the x and y component of the resultant. Now starting with the x component, so the first x component is this one, which is minus 43.30. Second x component is this one, which is actually plus 53.03, and finally the last x component, which is actually 0. So plus 0, you want to write it or not, it's up to you. Let's go on to the y component. So first y component is 35.35. It is positive, so it was actually this one. And then second y component is also positive, which is actually this one. it is 53.03. The third y component is actually negative here. We must mention the negative point, and that is equal to negative 50 because it is actually acting downward, this one. So it's this component. So let's calculate the x and y components. So our Rx become equal to okay. So we have negative 43.30 plus 53.03, okay, plus 0, so it's again 0. So it will be 9.73 Newton, that is our x, and then you can find our y, which will be 35.35 plus 53.03 plus 50, sorry, minus 50. Okay, where did it go? It's 38.38. Okay, so we got our x and our y components. All right, we got the Rx and our y components. Now we can go on and actually find out the resultant force. Okay, it's very simple and straightforward. Our resultant would be equal to square root of Rx square plus Ry square. This is what we said the equation will be. It's right here. Okay, so R is equal to square root of 9.73 square plus 38.38 square. Your resultant force become equal to, so let me calculate it. So we got what? We got square root of 9.73 and then squared plus 38.38 squared, and then I close the bracket. Okay, this gives us 39.59 Newton. Now we do not know the direction of it yet, so to calculate the direction we are just going to take the, because we know tangent theta is equal to Ry divided by Rx. Okay, so theta would be equal to tangent inverse of, what was Ry? It is equal to 38.38 and our Rx is equal to 9.73. Right, so let's go and calculate it. So we got tangent inverse of so it's equal to 75.77 degrees, almost approximately. So 75.77 degrees. Now what we have is we got both the magnitude, we also got the angle of the resultant force. So this is how we are going to go on for the when we are going to find out the resultant of uh, multiple forces. Right, let's go back to our presentation. So we just solved this problem, and I hope it is clear. If not, let me know in the comments. Now next topic is actually concept of moments. I would like to discuss this topic in the next video, so let's wind it up here for this current video. Alright, thank you. I'll see you next time in the next video for the concept of moment.